Hello all, welcome back to Project Mastery Podcast. We'll be covering schedule compression techniques, namely fast tracking and crashing in today's episode. Let's say you're a project manager who's executing the project. During project execution, you realize that there is a need to bring the project back on track. There is a deviation from the schedule baseline. You understand that the project is running behind schedule. How do you compress the schedule? You need to shorten the schedule, and at the same time, the scope should not be impacted. You should shorten the schedule without impacting the scope. This is where schedule compression technique comes into picture. You will have to compress the schedule whenever there is a project delay, or there could be a request from a customer to shorten the schedule due to market demands. You have to manage the schedule without changing the schedule baseline, which is nothing but the authorized time-phased budget for the project. Let's talk about fast tracking, which is one of the schedule compression technique. Fast tracking refers to a technique where you are going to perform activities in parallel that were initially scheduled to be sequential. You need to be aware of the schedule network diagram. You should take the critical path activities which were originally planned to be done one after the another or sequentially, and you're going to execute them parallelly. You will analyze the dependencies between these activities, which could be mandatory dependencies or soft logic like discretionary dependencies. You will find out the dependencies between these activities. You will analyze and then you will decide whether one particular portion of the activity can be overlapped or the entire activity can be overlapped for the entire duration. Overlapping task is something which happens as part of fast tracking technique. Overlapping phases or overlapping tasks. Let's understand when do we use fast tracking. When a project is behind schedule, you're going to use this technique. Whenever there is a task that's going to have dependencies but a partial overlap is feasible or a complete overlap is feasible, this is where you will do the feasibility study and you will overlap the activities. The advantage of this technique is there is no additional direct cost involved. There could be a cost of rework. Let's say activity B is dependent on activity A and you are performing these two activities parallelly rather than sequentially. Then assuming that activity B is dependent on activity A for some outputs, there's a change to activity A, then the activity B which was being executed needs to be reworked again. So there is always a rework risk here. You need to find out whether the overlap is feasible and then you need to use this technique. Once the overlap is feasible, it will definitely reduce the schedule. Increased chance of rework is one of the risks for this technique, and there could be potential quality issues if dependencies are not fully met. Let's take an example of a construction project where you want to start interior design work before all structural inspections are fully complete. In case of a software development project, you would like to begin system testing while some development modules are still being coded. In case of event planning, you may like to design the event marketing materials before finalizing the guest list, because both of these activities are independent and they can be executed parallelly. This diagram that you're seeing, this is a pictorial representation of the fast tracking schedule compression technique. You can see that activity A and activity B, two activities are involved in the critical path. Activities are performed one after the another, respecting their original dependency order. Activity A takes 5 days, activity B takes 5 days. Hence the total sequential execution time is going to be 10 days. No overlapping exists. Each task starts only after the previous one is completed. This is a safe time consuming approach. This is what we see before we apply fast tracking. After fast tracking gets applied, parallel execution takes place where activity A and activity B get executed simultaneously. Both activities run in parallel and then they converge at the end. Activity A takes 5 days. Activity B starts on day 3 while activity A is still going on and ends on day 7. So in total, it takes 7 days due to the overlap of 3 days between activity A and activity B. Overlapping activity shortens the project duration without changing the deliverables. You can reduce the schedule length significantly if dependencies allow partial overlap. The overlap correctly demonstrates that fast tracking reduces the schedule duration without changing the scope. The net reduction from 10 days to 7 days is realized here. A 30% time saving is what you are able to realize. If you look at this diagram, you come to know that there is a trade-off that's been made between the time saved versus the potential risk of rework if activity B depends on outputs from activity A. We'll move on to the next technique, which is called crashing. Crashing is a technique where you make resource adjustments. You are going to add a resource or you're going to make resource adjustments to shorten the project without impacting the project scope. Resource relocation is also crashing, where you're going to move the most experienced person to an activity on critical path, the most skilled person, the most costly resource to an activity on critical path. Adding additional resources is something that you do as part of crashing. When we say resources, we refer to people, equipment. It could also be overtime to speed up the critical path activities. When do you use crashing? You can use them when the deadlines are not negotiable. The most important thing is crashing is always done at a cost. There is always an increased cost that will happen when you employ a crashing technique. Only when a budget can accommodate increased cost, you can employ a crashing technique. And only when the activities can benefit from the extra resources you're going to invest, you will go in with crashing technique. Advantage of this technique is it will definitely reduce activity duration. It works well when you can apply these activities on the critical path. The greatest risk that you find here is the project cost. There is definitely going to be an increase in project cost. Resource over allocation is going to be there. There's going to be resource burnout. Team productivity will get impacted. Team morale gets impacted. If you take the example of a software project, hiring additional programmers to complete coding faster is an example. If you take the example of a construction project, adding more workers and shifts to complete roofing in half of the time. If we talk about a manufacturing project, running extra production shifts to meet delivery deadlines. All these are examples of crashing. When you do a comparison between fast tracking and crashing, you will know that time is the main driver for fast tracking. Time plus cost is the main driver for crashing. When you talk about risk, we know that quality or rework is a risk for fast tracking. Budget overrun or resource strain is a risk for crashing. When you talk about extra cost, there is no direct cost, but rework is possible in case of fast tracking. And in case of crashing, there is going to be a significant increase in cost. Activities can overlap as part of fast tracking. Activities can be accelerated with resources as part of crashing. Let's look at this diagram on crashing. Before crashing, the project follows the standard schedule with regular staffing and no additional resources. Moderate development takes 8 days, performed by the allocated team under normal conditions. System integration activity takes 5 days, performed by the existing team without extra effort. The total duration is going to be 13 days. This is the standard project timeline. No extra costs are incurred, but the timeline is fixed unless the schedule compression technique is applied. This reflects the baseline schedule in project planning. You need to apply crashing because there is an urgent non-negotiable deadline, and after you apply crashing, what are you going to do as part of crashing? Extra team members are added to task A, overtime is introduced for task B. Developers are added to model development task, duration gets reduced from 8 days to 5 days. Overtime is added for system integration task, duration gets reduced from 5 days to 3 days, hence total duration is 8 days. This shows how the project timeline can be shortened by 5 days with the resource investment. Faster schedule but with high direct cost is achieved here. Extra wages because of overtime. There are overtime payments. Potential equipment rental can also happen. You might even hire a resource as a contractor. There is an increase in resource cost. You will employ the best highly skilled costly resource to complete the work package and bring it back on track. A project manager must ensure the benefits, which is nothing but meeting the deadline, outweigh the additional cost and risk. We have covered all the concepts related to two compression techniques in today's episode, namely fast tracking and crashing. We have understood that every technique has got its own advantages and disadvantages. There are risks associated with every technique. You will need to read the project situation, understand which technique is apt for the current situation, and take the required actions in employing the right technique and reducing the project schedule without impacting the scope. We have come to the end of this episode. I hope the knowledge was valuable. Thank you for tuning in.